Today we're going to look at angular and linear velocity. So to start off with, angular velocity is how fast an angle gets bigger or larger. The formula for angular velocity is theta over time, and if you remember from yesterday, theta can be found by number of rotations times 2 pi. Remember, theta must always be in radians. So when you're reading these problems, you need to be able to see if you can find time. It may not to say, hey, it happened in 6 seconds or whatever. You need to be reading carefully and reading for understanding. So sometimes that's a challenge. You may want to use a highlighter to highlight certain things to see where you're getting your information. So example 1 says calculate the angular velocity in radians per minute, and that's really important. That's the unit they want our final answer to be in. Of a Ferris wheel that's 250 feet in diameter and takes 450 seconds to rotate once. All right, 45 seconds, that's my time. And they're telling me it rotates once. So that's going to tell me, that's going to help me get my theta. So my theta is going to be my one rotation from the once times 2 pi, which is 2 pi. And then I'm going to go to my formula. Angular velocity is theta over time. Well, theta is 2 pi, and time is 45 seconds. So right now we are in radians per second, but we want to be in radians per minute. So I need to convert my time. So we know that there's 60 seconds in 1 minute. My seconds will cancel, and then I will be in radians per minute. So then we go to our calculator. Clear that. So 2 pi times 60 2 pi times 60, and then I'll divide that by my 45 seconds here, and I get 8.38 radians per minute. All right, on this particular problem it says find the angular velocity in radians per second. So again, here's what they want my final answer to be in. Of a wheel turning 25 RPMs, and RPM stands for revolutions per minute or rotations per minute, however you want to look at that. So this is per minute, so my time is 1 minute. I've got to find my theta. Well, how many rotations? 25 times my 2 pi is my 50 pi radians. I've got my time, so I'll go to my formula. Theta over time. Theta is 50 pi radians over 1 minute. But we need to remember that they want my answer in radians per second. So then I need to convert. So 1 minute is 60 seconds. So now I'm going to be in radians per second. So 50 pi divided by 60 is 2.62. And that's radians per second. All right, linear velocity. Linear velocity is theta, again, the same theta I found in all the problems from yesterday, as well as angular velocity as well, times your radius over time. Well, with this radius, that's going to give me a linear factor, like miles per, and then time hours, or feet per second, or meters per minute, whatever. So again, we have to be very careful with our units. What else is important is to look at this formula. If you remember, theta over time was angular velocity. So another way to look at linear velocity is to say, oh, that's angular velocity times the radius. Or this was arc length. So linear velocity is arc length over time. And you may need that for some of these problems because they get a little tricky if you're trying to go backwards and find radius or something like that. You need to realize there's a relationship with all those problems. This formula, I will give you these derivations of it. You will need to be responsible for. So example 3, we've got the wheels of a truck turning at RPS. So that's 6 rotations per second. So 1 second is my time. The wheel has an 8 feet diameter, so that means my radius is 4 feet. And first I want to know what the linear velocity of a point on the edge of the wheel is in feet per second. And then once we get that, they want me to convert it to miles per hour. All right, so the first thing I always need to find is theta. Theta, again, is rotations times 2 pi. 6 rotations. So that gives me my 12 pi. Go to my linear velocity formula, theta times r over time. So I've got 12 pi times 4 feet over 1 second. And then I need to look, what unit do they want me to be in first? Feet per second. Well, that's what I'm going to be in when I multiply this through, so that's great. So 12 times pi times 4. And that gives me 150.8 feet per second.